Hey everybody, I'd like to teach you a couple of tips on how to integrate your code into Unity to keep your code lightweight enough so that you don't ever get bogged down. Whenever you go to Patreon or Kickstarter and see all those failed games that never quite go anywhere, it's not because those people are scammers, it's because game dev is hard. You can get far enough along that you can put out a pretty decent prototype, but then you realize that you can't get along any further. Your code base has too much technical debt, it's architected wrong. And you don't really know how to fix it because, I mean, you're not a pro at game dev. So I'm going to go ahead and show you some tips on how to fix your code architecture here in Unity to keep things lightweight. This is useful for making sure that you can move forward easily on games, both in the beginning and as you advance along. It's also useful for going back and fixing things that don't work now. You can just change them so they do this sort of thing. There are lots of code architecture classes you can take and fundamentals you can learn. These are specifically for Unity. So you're going to need to know some Unity and some C#, but you don't need to be a pro. We're going to create a shop and player script and player inventory system in one little video. It's going to be a long video, I'm afraid. And since I'm leaving tomorrow, I don't have time to wait for the party behind me to stop. So if you hear party music, that's some people having fun, and I don't begrudge them that. But it is a little loud. So the idea here is that the inventory is obviously going to contain items, so we'll just pull up an editor of our choice and put that in. Public list items. Some people say you shouldn't use lists because they're slow. Those people don't know what they're talking about. You can ignore them quite safely. Those kinds of lists are very fast, and unless you are doing millions and millions of operations per frame, I wouldn't worry about it. Just use lists. But those are classes, not objects. Let's go ahead and create some objects. Here's an inventory, which we'll drop our inventory onto. And then we'll also go ahead and create some... That's not how you spell apples. There. And then drop the item in here. And we'll create some more of these. So I've been doing a lot of cooking shows recently, so we'll go ahead and put in some cooking stuff. We'll make a cooking RPG. And our cook will need a cooking knife, so +3, Demon Slayer, God, Sword of Kings. That's not Kings. Well, close enough. It makes a pretty good cutting knife. There we are. The problem is it's not actually in our inventory. Although it's physically inside of the inventory object, the inventory script doesn't actually understand that. So we need to set that up manually. Later on we can automate it, but for now we'll do it manually. There we go. And now we have an inventory full of stuff, but this is only an inventory in the scene. If we went to a different scene and tried to access it, it wouldn't exist. So we're going to drop it into a new folder, which we'll call prefabs. There we go. Boom. You might be thinking, wait, didn't you want to have like apple, chicken, butter, each its own prefab? Nope. That's one of the tricks I'm going to teach you today. So let's go ahead and create a UI. We're going to create a fast, ugly UI. Just because, you know, I need to have something to show you. Obviously, in your UI would be very pretty and gorgeous, and you would spend hundreds of hours on it. It's just that we don't really have that kind of time right now. So this is going to be our shop. We'll go ahead and make it an opaque white, and give it a vertical layout group here. And we'll add in a button. The button is definitely not correct, so we'll go ahead and change up the panel's options here. We want it to be wide but not stretched tight on the top, not stretched vertically. So that way they stack up nice like this. And then we'll just duplicate that, and this one will be the shop, and this one will be the player inventory. Obviously these buttons don't do anything right now, they're just there for looks. We've got to make them do something. Now, some devs, what they would do is they would make each of these buttons an item. So this would be apples. Now, the problem with that is that it is a bad approach. You do not want to tightly link your definitions and your UI logic because your UI logic has hundreds of different contexts. And you're going to end up really getting bogged down if you try and make the item keep track of the context. So the item is just a definition. It never gets put into the game. You'll never see the apples, chicken, or butter actually in the scene. It's always just going to be a reference. So we're going to need to have something that does that for us. Go ahead and create a new script, which we'll call item UI. Now my preference is that when I'm creating a 2D UI element, I use the UI suffix, and when I'm creating a 3D one, I use the display suffix. But that's just my preference. It's not like some global standard. And we're going to need to put in some UI here. So there we are. We're going to have a text box, but you could easily use an image and use a sprite or something similar. And we're going to go ahead and do a public virtual void display item. This.item equals item, and then we go ahead and say that item name.text equals item.name. Here in start, we'll do a little shortcut for debugging purposes. We'll say if item, then display item. That way we'll be able to test it without having to do too much work setting up a scaffold around it. So with that said, almost all of these buttons are worthless. We'll just delete all of them except for one. Boom. And then this button will become our item UI button. There we go. I'll drop the text box inside of it, and we'll give it a link to apples. Boom. And then we'll just duplicate it a bunch. There we are, apples. Now, these don't mean that there are 7 apples in the scene. There are 7 references to the concept of apple in the scene. This is an important distinction that you're going to want to make. The inventory to item ratio is not 1-to-1 or even many-to-1. It's many-to-many. That is to say, I can have 100 different inventories with this apple object in it. This apple object is not replicated and put into new inventories. Every inventory just uses a reference to it, including this one. If we removed the apple, air quotes, from this inventory, it wouldn't delete this apple object. It would simply stop pointing to that apple object. And that's an important distinction because there are a lot of times when you need to change something or understand how references are being made. And keeping it as simple as possible is important. And as simple as possible means there is one data object. There is one thing, one central point, and everything else refers to it. And in this case, this is the only place apples will be found, unless you're doing something unusual like creating a variant. So that's important. These are not actually Apple objects. They're all just Apple UI objects. But what we need to do is create an inventory for the shop, because we don't want just random references floating around. That's not really very helpful. We need to make it so they do stuff, right? So we'll create an inventory UI. This inventory UI is just going to be basically the same thing as the item UI. It's going to inventory, take in an inventory. And it's also going to have a transform target for the list of things it's going to be creating. In this case, it's actually going to be us, the same target, but there are lots of times that's not going to be the case because you'll have a shop full of people and stuff. So we're going to create it so that the content can be any subdivision or any transform. And that's going to be just useful. You'll see. So here. Party's a little distracting, sorry. Item UI. UI prefab. Or item UI prefab. Oh, come on, Craig. So anyway, we're going to want to have a semicolon. Public virtual void display, and we're going to go ahead and ask it for an inventory, and then we're going to say this.inventory equals inventory. We're going to separate out our visual refresh into its own little section, because this is something where we may actually call it hundreds of times over the course of a transaction or a scene. So we don't want to be continually setting and unsetting the inventory item here, because there are lots of other things that this is going to do when we set it and unset it, so we don't want to screw that up, right? We want to make that as easy as possible. So we put that in its own little place, and when you refresh, it's not going to have any sort of setting or unsetting of the inventory. It's just going to change the item UI stuff, right? So for each item I in inventory.items, UI or item UI equals item UI dot instantiate item UI prefab, and then put it in our content transform. I always use this content rather than this dot transform, and you'll see why in a second. And then we just say UI dot display item I. There we are. And that should work fine, except if we call this lots, we're just going to get more and more buttons. We're not clearing away the old buttons. So we also need to remember to clear away all of the old buttons. Destroy t.gameObject. That should work fine. And you can try and reuse them and pool them and stuff like that, but this sort of thing generally doesn't get called very often, and it's generally not a high load situation, so you don't generally need to worry about performance. Although there are exceptions, obviously. So what we need to do is create that. Now we could put it here in the shop. We could put our inventory UI right here. Problem with that is that we're not going to be able to look that deeply when this shop is... so if we were to create this shop as a prefab, which, you know, eventually you probably want to do, right? You can only look one layer deep. And therefore, putting it here means that you wouldn't be able to edit it from the prefab. So we're going to put it up here at the top, just as an ease of use sort of situation. And we're going to want to then tell it that this is the transform way down here. All of these buttons can be deleted, and we're going to rename this to shop item and put it in our prefabs directory as a new prefab. And then delete it, and then add it in as a reference here. Oh, I dragged the wrong one. There we are. And then what we can do is we can just drop this inventory in as the inventory in question. When we hit play, it didn't do anything. Oh no! Why didn't it do anything? Well, we forgot to hook it up. You see, this never gets called, so we're going to go ahead and call it. If inventory, then display inventory. Nope, I pressed play twice there, but you see it. All works. Nothing happens, but it works. Now the problem with this is that probably don't want this inventory item to be the inventory of the store, because that would mean that the store would be editing some kind of core inventory, and that's not really a good idea. We'd like to have the store's inventory be its own thing, right? This is not the inventory for the store. This is all cooking inventory. This is the list of all of the cooking inventories. So when we want to get a random cooking item, we can just get this cooking inventory and ask for a random item inside of it. This is the reason I like to use game object prefabs rather than scriptable objects. I think a lot of people would put apples, chicken, butter, and the +3 sword each as a new prefab in a subdirectory. I don't like that because it's hard to automatically correlate with those directories. So you'd have to manually scan them or manually add things to a management system. And I just think it's easier to do it like this. We can just use the nature of game objects to stick all of the items of one sort inside of a game object that keeps track of that. And in that way, we'll be able to call for random items and stuff like that without any difficulty. Modders can add new items to it without any difficulty, and we can alter any of these items, and they'll instantly alter across the entire game. If they were floating around on their own, they'd be harder to keep track of, and modders would have a harder time adding in more items, and of course you might have a harder time adding in more items as well. So this is my preferred approach, but it does mean that we need to have the shop have its own inventory. Well, get this, the shop can have its own inventory. There's absolutely no difficulty with that. Just bang, there it is. Bang, there it is. And that means that we can now create our own custom inventory which references items within a different inventory in our game logic down here. And of course, if we change this from a +3 sort of Demon Slayer sword to a +1 Demon Slayer sword, that would change in the inventory as well here, because it's just a reference. So if we hit play, you'll see that that works fine. This is an important thing to understand. All of your code needs to be as simple and flexible as possible. In this case, inventory is something where we can put it on an object in the scene and have a custom inventory. We can put it inside of our game logic systems and have a custom inventory. We can put it as a directory in prefabs and have a custom inventory. And all of those things simply serve to contain items. Because there's no logic code in them, they're just containers, we can put whatever logic code we need around them. And this is a really, really powerful way to think about all of these sorts of things. You want to use a few simple modular objects rather than some complex, nasty web of objects. And that's just what Unity uses easier. So in this case, it's very easy for us to edit this and just add or subtract items from this list here. It's trivial. This is the secret sauce that you're going to want in order to do this yourself. The items, the inventory is not part of, the inventory doesn't understand that there's a shop. The inventory is just a container. And then the shop has its own special custom interactions. Well, that part's what we're going to get to now. How do we create custom interactions? Obviously, we want things to happen when we click. We'd like the player to be able to buy this stuff. How do we do that? Well, the big problem is that we don't know what the player's inventory is. We don't know where it is. We don't know what's going on. The player could be playing 3 different party members, or maybe they're back in time and they're playing as Sephiroth. How do we keep track of which inventory is the player's inventory and refer to it? This is a very common problem in game dev, especially here in Unity. Some people use a singleton. I use singletons all the time, or makeshift singletons all the time. And that's when you just have something like a universe object and everything gets put there and then you go fetch it. In this case, I think there's an easier option. And there are several ways to do this. And I think that the way we're going to do it today is we're going to add in just a quick little Boolean toggle into our inventory. So we're going to add in a public bool player inventory equals false. And then here, public static inventory player inventory. There we are. Here in start, we're actually going to want to do this in awake. Oh, I've got 2 things called player inventory, sorry. Is player inventory. There we are. So awake is slightly different from start. Awake happens first. And so you want to keep track of what things go in awake and what things go in start. In this case, we're trying to set something as a global variable. So we want to do that as early as possible so that anything that accesses that global variable during start can be assured that that global variable already exists. If they're going to reference it, it needs to exist, so we're going to do it first, right? So if is player inventory, then player inventory equals this. Quite simple, right? Now any inventory with this as true will pop up as a player inventory and it will be tracked. So let's go ahead and create a new item down here outside of everything. We're going to call this a player inventory. And we're going to actually rename this to a player inventory UI because it's important to understand the distinction. This is not a player inventory. It's just a display. The player inventory is being carried around by the player object, probably. Might be a prefab, who knows. But this is what's going to be our player inventory. We'll drop this on here and we'll toggle that. There we go. Go ahead and add a couple of objects so that it, feels like it exists. Apples and butter. There we go. Now, how in the world do we get this to work with that? Well, what we're going to want to do is we're going to want to have a function that when we click on one of those buttons, it gets added to this list and removed from the main list here. But obviously that doesn't happen yet. So we need some logic that will allow that to happen. And there's 2 pieces to this. One is actually calling that function, and the other is how that function is part of the UI. That is, you have to trigger it and then you have to actually do it. We have buttons, but they're not connected to anything right now. The shop item button doesn't do anything. So what we need to do is we need to make it do something. And that means that we're going to want to add here to this item UI a new function, which we're going to go ahead and call public virtual void click. Easy as pie, right? And then here, we're going to drop it in. Click. So what do we want this to do when it's clicked? Well, if you've ever created a game, you might be like, well, obviously what you want to do is you want to search for the inventory UI that's part of the parent and then find that and do that. And then, no, that's too much. The item UI needs to just be blind. It needs to not have any logic built into it at all. So we're going to use events so that the inventory UI can do all the heavy lifting and the item UI can just be there to display the item. And that's an important technique here. You want to centralize this sort of functionality in a way that doesn't cause spaghetti code. Using Unity Engine.events. So the problem here is that when we create a Unity event, this shows up just fine in the editor, right? So when we go down here and we actually access it, grind, there it is. The problem is that we would not know which item was actually clicked. This is a nothing. There's no argument here. Now, if we manually add in some stuff, we can do it. So if we were to just manually add this shop in, oh, we can't. Why is that? Well, it's because this prefab has nothing to do with the shop. So we can't connect them. They can't be connected. We're going to have to write code to connect them. And we've got two basic options for how to write that code. One is we can try and work with anonymous functions. And the other is we can try to get Unity to throw an event that is a little better. We're going to go ahead and have Unity throw an event that's a little better. This is a little bit deep magic, and this is the only part of this that is like actual technical knowledge. The rest of it is just architecture stuff, but this is something that Unity doesn't do very well, and you have to work around. So the basic way to do it is you say Unity event item UI. That works, except that this is actually not a class that you can just instantiate. It's a virtual class, I believe. And that means that it doesn't actually run. It never works. Instead, what you've got to do is descend from it. And this is really kind of stupid, but this is how you do it. You write yourself an item UI event, and you descend from Unity event item UI, like this. And you get yourself a little factory going, right? So there we are. That is an item UI event. Oh, public class, my bad. That is an event that actually can run, it actually can be instantiated, but Unity still won't recognize it as something that can be displayed. Watch. So if we switch this over to an item UI event, and then we go back out here into the scene view, and we wait until it recompiles, boom, it's gone. It's gone! Oh no! Yeah, Unity doesn't actually realize that this is serializable unless you tell it. So this is one of the things that I repeat all the time. And it is definitely the most annoying thing about using Unity events. If you want your custom Unity events to throw something with an argument, you need to do this stupid descend from Unity event with a new custom class and then tell Unity that it's serializable nonsense. And this is the only thing I really, really hate about working with Unity events, but it's not too bad once you understand it. There we are. And then down here in click, we'll say unclicked.invoke this, and that will work great. The only problem is that right now nothing is listening. We can click all we want, but nothing will happen because there's nothing listening. Oh, sirens. So how do we make stuff listen? Well, we make the inventory UI actually listen for it. So in order to do that, down here we say UI.onClicked.addListener, and then we pass it a function. So UI clicked. There's no function called UI clicked. We'll go ahead and create one. There we go. And for now, we'll just go ahead and destroy it so that we know that it's actually doing something. And we'll just go ahead and test and make sure that that chain actually works. Yep. So what we've done is we have created an item, we've created an item UI that when you click it, will throw this event. It has no idea who's listening or anything. It just says, hey, I was clicked. Anybody that cares, raise your hand. This guy, when he creates them in the first place, he adds a listener and he waits for them to get clicked. And then when they're clicked, he reacts. So how does this inventory UI react? Well, what we want to do is have this get added to the player's inventory. So let's go ahead and just code that up first. We'll go ahead and say inventory dot player inventory dot remove. We don't have a remove or an add, so we're going to go ahead and add them. So we're going to want to add our item, and then we're going to want to remove it from ourselves, right? So inventory dot remove IUI.item. Now the problem is that add and remove don't exist yet, but that's pretty trivial. We'll go ahead and just add them. You might be wondering why we want to have it like this rather than just manually saying items.add or anything. And the reason is because there's lots of stuff that happens when this happens, and we don't want to have that fire in an unusual pattern. Also, what we're going to do here is we're going to put in a special case down here in remove, just in case. So if items.contains item, so if there's no item of that sort in it, we're going to return. And the reason is because we don't want to accidentally trigger too many things. We haven't added any triggering code yet, but we're going to. And we're not going to put that around. We're not going to put that here in the add because you could have multiple apples in your inventory. Obviously, we could also track like an inventory container item where you're tracking how many apples you've got. But that's a different topic. In this case, each apples is just one unit of apples. So you can have like 10 and they'll all be lined up on the screen. So that should all work fine. Let's go ahead and give it a shot. We'll highlight the player inventory down here. Take a look at apples and butter. Click. There's our chicken. It gets added in. And that's interesting because now there's no chicken here in the inventory, but this didn't update. Well, that's what I was talking about. We've got to tell it to update. And the way we're going to do that is we're going to fire off a Unity event. And that should be fairly straightforward. So public void, public Unity event unchanged. And then down here, we're going to want to have that happen. Unchanged.invoke and unchanged.invoke. That's pretty straightforward, not too bad. Here in the inventory UI, we're going to want to actually sign up for that. So this.inventory.unchanged.addListener refresh. Whenever you add a listener, you want to get in the habit of removing a listener, just in case. Now, this isn't so important with Unity events. C# events are really aggressive about this, but Unity events actually have a lot of automatic checkups and stuff to make sure nothing too bad happens. But it's still better to get in the habit of making sure that you remove any sort of event that already exists. So this.inventory.unchanged.removeListener refresh. That way we won't have any problems with it getting signed up for hundreds of times, right? With that in mind, now that when we hit play and we click on this chicken, oh look, it properly reflects what's going on. And here you can see that we've got this setup where now we have everything in the player inventory, but it's not showing up. That's because there's no inventory item over here, no inventory UI over here. The problem is, if we have an inventory UI here, how is it going to get a reference to the player inventory? Well, we already know how it's going to get a reference because the player inventory volunteers thanks to this Boolean we've created. But how do we tell the inventory UI that it should be getting the player's inventory? Well, we could create another Boolean, or we could create a inventory UI descendant class. For now, let's just go ahead and create another Boolean. Creating Booleans can be messy. You can end up creating too many things. There are lots of other alternatives. We could descend from inventory UI and create a player inventory UI and then override start so that our version of start just grabs the player's inventory. Another option is we could have a plugin, something that we toss on, a mono behavior that we put in that searches for an inventory UI on this object and then injects the player UI. I think in this case the Boolean is pretty straightforward though, so we'll just go ahead and say show player inventory equals false. And then here in start we'll say if show player inventory else, so display inventory dot player inventory. Now this is in start. So we have to make sure that player inventory gets set before this gets called. We could try and use like a script execution order hack, but in this case, the easiest way to do it is to make sure that this happens during awake, because awake happens before start. Pretty straightforward stuff, right? So here, we're going to drop a player inventory system. Yep, and click. we'll drop in the things we're going to need in order to set that up. There we go. And we'll save that and hit play. Boom, 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 boom. And there we have it. But I think we want our player inventory to do some different things, right? We want it so that when the player inventory gets clicked, something else happens. Right now, our inventory UI is a one context sort of creature. It understands how to get the player's inventory, but it doesn't have any sort of concept as to what sort of action it should be taking when something is clicked. Well, if we want to give it some sort of do something when you're clicked, what sort of logic are we going to use? Are we going to program in a long function? It's like, if this is in a shop, then do this and charge money, and if this is in the player's inventory and he's in combat, then he can't equip, but he can use items. And oh, that sounds complicated, doesn't it? Whew. Let's go ahead and put that logic in something else. This is one of the keys to making sure that you have a fairly lightweight set of classes. I prefer more smaller classes when doing game dev if possible, because most things that I build in Unity are agglutinates. They have several mono behaviors on them, and those mono behaviors teach them how to act. So what we're going to want to do here in this inventory UI is we're going to want to create a new event that will react and trigger something else on this object that can do whatever we need it to do. So we'll go ahead and create that. Now, as before, we're going to have to create a new class to do this because, again, this is Unity being a little silly. We're going to call this an item event. And we're going to give it system.serializable. But you know what? This isn't really a good file for mono behavior. That was supposed to be a mono event. Unity event, my bad. There we are. But this isn't really the right place for that. We could put it in its own file, but I think it's okay if it goes in this file. So we'll go ahead and just pop on over here and add it in. That's just to keep it a little clean. Now, you should have no problem finding it because you can always just double-click on whatever you're trying to do, and it'll pop on over to wherever it's defined. It's pretty easy, or right-click, depending on what you've got. You can go to declaration and find references and stuff. It's not hard to track down, but I generally try and keep it a little bit clean. So what we're going to want to do is here in the inventory UI, we're going to want to trigger that. Public item event, item selected. And then down here in the UI clicked, instead of doing this, we're going to want to have an item selected dot invoke. And then we'll pass it in at the IUI dot item. There we go. And then we can hide these for now. So if we do that, then what we end up with is the ability to actually set an object, or set a function call up in here rather than in code. This is an important feature of Unity. The scene is very powerful. This editor is very powerful. This inspector is very powerful. There is an urge to create code. You might want to think about creating less code and more mono events, or more Unity events rather, because these Unity events are very easy to arrange in really, really interesting ways, especially if you need to have special logic for one given shop, or an instructional thing where the first time you visit a place, it's a special shop that pops up stuff and talks to you. All of that stuff is much easier to do using Unity events, because you can just create a one-off instance and set the Unity events up however you want. Now in this case, what we would like to do is have the player inventory eat the item, and what we would like to do is have the shop inventory move it to the player item. So we don't have any functions to do either of those right now. There are a couple of ways to handle it, but I think the easiest way is just to put some more functions here. We're going to put in a little bit of a comment section where we say code referenced by Unity events only. And this is obviously optional, but then you can also put in a code region You don't have to, but if you're real clear about this stuff, you're going to thank yourself 2 months down the line when you're like, oh crap, what reference is this? One of the issues is that when you're using Unity events, right-clicking and selecting Find References isn't going to find references because they're in Unity events. So, public void add to player player inventory item, and that's going to be this. Public void remove from own inventory item. Oh, this doesn't need that. And that's going to be this. And then we're also going to want to have a use, public void use item. Now when we use it, we can have any sort of logic we want, but let's go ahead and add some logic here into the item. Public bool consumable equals true. And then here in the, we can also create a, we actually can make this a more complicated set of systems. So public bool use, and then we will go ahead and say that it returns true if item is kept, false if destroyed. There's lots of reasons why this might be a good or bad setup for you, but we're going to go ahead and just return not consumable so that if it's consumable, it returns false. And then what we'll do back here is we'll say if item.use, so if we didn't use, if the item didn't survive, then we want to remove from own inventory item, right? So this is a very simple setup where we can set these things up as Unity event responders. Now this is a fairly aggressive version. Some of the times you might want to just create more complicated single-use functions. The reason I'm doing it like this is just to show you how flexible this can be. So what we're going to want to do is have this call our own inventory UI use. And you can see how it's asking for an item. Well, that's because we need to select it from up here. It's pretty basic. Down here in the main system, we're going to want to have this run twice. It's going to remove it from our own object and add it to the player object. I don't believe that the order is going to matter in this case, but we'll go ahead and make it so that it adds before it removes. We could also, since we actually know where the inventory is, we could call the inventory itself for our remove. We don't have to call the local remove function if we don't want to. This sort of thing, it can get a little bit dicey if you've got lots of functions that do similar things. So, you'll have to try and feel your way through there if you're not comfortable with your architecture. We're not going to save this scene. We're just going to push through here. So what happened? Well, if you can see, it runs fine. All of that stuff works fine. We have now bought and used everything. The last thing we want to check here is if this can be checked as a non-consumable item so that when we use it, it doesn't actually go away. Yep, works fine. Now, obviously, the item doesn't actually do anything. You might be wondering, well, how do we make it so this item can do stuff? Well, in general, rather than having the item, don't descend from item. Don't have like potion item and then sword item and that sort of stuff. Instead, you want to have plugins. So we're going to create an item add-on or an item mix-in, however you want to call it, right? The item mix-in is just going to be something that has a simple function, public void use, right? A very basic setup like this, virtual void use. And then over here in the item, what we're going to want to do is find a list of all of them and use them. So item mixin, mixins equals get components. Now you can use get components in children or get components, whichever one you prefer, depending on how you plan to set these items up. We're just going to use it right here. True. And then we say for each item mixin in mixins, mixin.use. Easy enough, right? So what we're going to do now is we're going to fix our code error. Cannot convert bool. The best overloaded get components method has some invalid arguments. Oh, it doesn't need this. Sorry. I'm used to using get components in children. There we are. So with that in mind, why did we do it this way? Well, this has a significant advantage because we can have an infinite number of mix-ins. So healing mix-in, or we'll call it a mix-in healing, just because that way we'll be, they'll all be in order. You can also use namespaces and stuff. This is not terribly, this is a straightforward concept, and we're just kind of winging it to get done quickly here. Since the mix-in healing is part of this, we can just say public int heal amount equals 10, and then we can override use and say debug.log healing and then heal amount. Now, obviously, we don't have any concept of who the item is being used on. We could make this a lot more complex. For example, we can have the inventory be responsible for telling us to use the item rather than the inventory UI. So this is just removing and using and stuff. What we may want to do is move that into the inventory, because the inventory can keep track of who it's on and that sort of stuff. For now, however, this is going to work fine. And this will be our heal amount. And then the reason that this is important is because now I can also create another mix-in, which we'll be calling mix-in a stat boost. And obviously we don't have any concept of stats, so we'll just have a public string stat equals strength, and public int amount equals 5. And you might obviously have a different way to handle your stats. It doesn't really matter. Oh, I forgot to descend. Hold on. There we are. And we'll just go ahead and say debug.log boosting stat amount. There we are. So why did I make these separate from item? Why didn't I descend from item to do this? Well, that's because this way I can actually have a lot more complicated setups. So here, for example, we can add in a stat boost, and we can have it be a strength of 5. But for our butter, we could add in a healing and a stat boost. And for chicken, or apples, we could add in a stat boost where it boosts intellect, but it also decreases strength. See? These items can have any number of mix-ins on them, so you don't have to worry about having multiple effects or complex custom effects. And you can even add in stuff like a mix-in whose only purpose is to fire off a Unity event so that you can set up that Unity event to do some tutorial stuff. Why not? Have a custom version of Apple where when the player eats it, it fires a custom Unity event that triggers the next part of the tutorial. So with this in mind, when we do this, they just get added to our inventory and we don't see any use pop up. But when we actually use them, boosting intellect 5, boosting strength -2, boosting strength 5, healing 10. And then down here, we have it doubling up on the strength. See? And the chicken doesn't do anything. So this is a very straightforward method to try and create as much extensibility as possible. The idea here is that you don't want to have code which has a specific purpose locked to other code which has a specific purpose. The more specific purpose code you have that calls other specific purpose code, the harder it is to break into that chain when you need to change directions. So if you are descending from item, then you're stuck with the fact that all of your items can only do one thing. If you put your display logic into your item class, then your displays can only do one thing, and you can only have one display per item. If your inventory, if you have a shop inventory class and a player inventory class and whatever else, those need to have a lot of code to try and create a context for whether or not they need to run things at runtime. So the player inventory, if the player inventory is responsible for figuring out what to do when someone actually uses an item, then that would mean that the player inventory would have to have variants for an in-battle player inventory, and a different code branch for the out-of-battle inventory that lets you equip things, or two separate player inventories, one for equipable objects and one for battle objects, but then you couldn't throw swords because those are equipable objects. Yeah, it's much better if your logic is split into tiny chunks, and then you can wire those chunks together using UnityEvents. This is a very, very basic setup where I have all of the stuff that we need to create a fully functional shop and player inventory, but I only have a couple of scripts, and they're all very, very simple scripts. None of these scripts are longer than maybe 20 lines. I think the longest script we've got is this one, because we've got some Unity event responders here so that we can wire stuff together using UnityEvents. But this inventory UI isn't a special shop inventory setup. It is just a normal inventory UI with some custom events thrown in. And if I wanted, I could have other custom events. I could have a custom event where it turns itself off, so you can only buy one thing. So if we drop this in and then we say game object set active false, now we've created a version of the shop where if you buy something, the shop closes. Now, obviously, you'd probably want to put in like a pop-up where they throw you out or whatever, but I just wanted to show you this basic idea. It works fine. And this is a fully distinct prefab. I can create a new scene, drop this prefab in, and it will just work. The player inventory can be a different player inventory. It could be however you want. There's no reference to any outside objects in here. So if I were to grab the special shop here and then create a new scene, and don't bother saving it, paste it in. The only problem is that right now there's no player inventory, but if we had a different player inventory, that's not the right button. And now we hit play. There it is. It works the exact same. Oh, sorry, I pasted it in, but there's not actually any. There's a special event system that has to be in here. It gets added automatically, but I cut and pasted, so it didn't. There we are. And there we go. That was the special close down event that I added in. I can remove that because I think it's a little bit. Oh, that was the wrong thing here. This, please. I want to get rid of this. There we are. That was annoying. So hit play. There, see? Same stuff. Even boosting the strength the same way. This is a very, very basic setup. It's something that you can put into any scene. You can customize it for anything down the road where you decide that you need a different kind of shop or you need your shops to do a different thing. It's all very simple because you can just stick your fingers in wherever you need them to be. If you need the shop to charge gold or not charge gold, rather than having like a new branch of code, you just put it in the event. You say charge gold, and here in the item selected, charge gold for that amount of item. You know, it's a very, very basic setup. It works fine. And you can do this without having to worry too much about your technical debt because all of this is very lightweight. Later on, as you get further along with your game, you may find that you want to cement some of this down to create a more fluid structured method of handling this, and that's fine. But if you do that early, you're going to kick yourself later because you probably don't really know what that structure should be. This is a structureless version. It's a version that you can just toss around and fix up, and if it breaks and you don't like what happens, replacing it takes less than an hour. Anyway, I got a plane to catch. I'll see you guys in a while.